All right, you found the quick review, and I'm going to try to make it quick, but there's a lot here in this lesson. So we are dealing with multiplying like bases, right? And so if you remember, you add the exponents, right? When multiplying like bases, we're going to add the exponents. Okay, well, I chose an interesting example. It's got coefficients as well. So you're going to do 2 times 3 is 6. 6 times a -1 is a -6. Now you're going to deal with your exponents. And notice we have like bases. So there's 3 of them, but that's okay. We're going to add the exponents, right? 12 plus -4 plus, don't forget the 1, right? Though it's not shown, there's a 1 there. So where do we end up? -6n to the 9th. Make sense? Hope it does. Using the exponent rule to multiply like bases. All right, remember, to divide like bases, you're going to subtract the exponents. The top exponent minus the bottom exponent. Remember, it's just a shortcut. We went over all that in detail in the main lesson and last year in Algebra 1. All right, so something like this. Be careful with the coefficients. The 20 doesn't, this 7 exponent does not belong to the 20. Don't misappropriate the base. So you're going to reduce. What's 20 divided by 5? All right, that's a 4, so that's that part. Now do your exponents, right? N to the 7 minus 2, and that's going to be 4n to the 5th, right? Make sense? Okay. Next one. What happens when you have a base and its exponent to another exponent? Well, you multiply the exponents. Again, this is just a shortcut. It's a time saver. You can always do it longhand, but you'll be there forever. Now, again, don't misappropriate the base. In with that, this number 2 has a 1 exponent. So notice the base has 2 things that are multiplied. Therefore, it's going to be, I have my 3 times, now let's do my base, 2 to the 1 times 2, right? The 1 times 2, n times n to the 5 times 2, right? So look where we end up. 3 times 4, right? 2 squared is 4, times n to the 10th for 12n to the 10th. Just take it one step at a time and you'll get there. All right, I got to hustle here. All right, remember, anything to the 0 power is 1s. Why? Because it's the base divided by itself. Again, be careful to only apply this to its base. So this is a 4. Whoops, sorry about that. So this is a 4 times n to the 0 power, or 4 times 1, which is 4. Be careful on that, right? Only the n is to the 0 power. Okay, what else? Hey, don't forget negative exponents. A negative exponent in the numerator is a positive exponent in the denominator. A negative exponent in the numerator is positive in the denominator. Negative exponent in the denominator, oh, I hate when it does that to me. Sorry about that. Negative exponent in the denominator is a positive exponent in the numerator. Okay. So let's deal with this. All right, first off, the 5 is just a 5. It just sits there. There's no other numbers, and so it's just going to be a 5 when we're done. So we're going to have a 5 in the numerator. Now just take it time at a time. Here, I got an a to the 4th divided by a to the 2. You can either do the division rule, or you can take these a's into the top, and now we have a to the 6th in the top, right? I mean, it's that easy. N to the -7, take it down below because you shouldn't have any negative exponents. Z to the -4, take it up top because you shouldn't have negative exponents. There you go. You're done. Away we go. All right, last one. Wow, it's hard to get these algebra 2s to be 2 minutes or less. Hey, just be careful with a problem like this. You got to distribute this -3n. So -3 times 2 is a -6. N times n squared is n cubed. -3n times a -4 is a positive 12n. Now see if you can add like terms. 7 of them, the n cubes, minus 6 of them, the n cubes, leaves you 1n cubed. -9 of them and a positive 12 of them leaves you a 3 of them of the n's. Hey, there you go. Some simplifying algebraic expression.